Did you know merge two sorted lists is one of the most frequently asked questions at Phong interviews? It's a favorite because it checks your understanding of both pointers and real algorithmic thinking. Over a third of candidates stumble here, but with the right method, you'll be able to merge any sorted lists, just like magic. Today, we're turning this Pattern Mastery 100 staple into an easy win.
Ready? Let's dive in. First, let's break down the problem. You're given two sorted linked lists, like List 1 and List 2 in the image above. Your goal? Merge them into a single, sorted linked list. The trick is, you should do this by reusing the existing nodes, not by creating extra arrays or data structures. Let's assess the challenge. A brute force approach could be to collect all the values, sort them, and build a new list, but that wastes space and time. The optimal way is to use two pointers, one for each list, and merge them as we go, node by node. The merging will be done in O(n) time and O(1) extra space, since we're just changing the next pointers. Now, let's structure our approach. Create a dummy node to serve as the head of our new merged list. Use a pointer, tail, to track the end of the merged list, while both lists have nodes. Compare their values. Attach the smaller node to tail. Advance the pointer of the list from which the node was chosen. Once we run out of nodes in one list, simply point tail dot next to the remaining nodes in the other list. Now let's solve solution 1, merging two sorted linked lists iteratively. We'll go step by step, understand how to pick the smaller node each time, and build a new merged list. Time complexity is O(m) plus n, where m is the number of nodes in L1 and n is the number of nodes in L2. Each node is visited exactly once. The idea: use a dummy node to simplify list construction. Keep a tail pointer that always points to the last node in the merged list. Compare the current nodes of L1 and L2. Attach the smaller node to tail and move that list pointer forward. Once one list is exhausted, append the remaining nodes from the other list. Think of it like merging two sorted lines of people into a single sorted line, one person at a time. Line by line explanation of the code, we define a class solution to hold our method. This function takes two sorted linked lists, L1 and L2, and returns a merged sorted linked list. We create a dummy node with value 0. It acts as a placeholder to simplify building the merged list. Tail points to the last node in the merged list. Initially, it points to the dummy. Loop as long as both lists have nodes. We will pick the smaller node from L1 or L2 each iteration. Compare the current values of L1 and L2. If L1 is smaller, it should go next in the merged list. Attach L1's current node to the merged list. Tail now points to this node. Move L1 to its next node. We've already added the current one to the merged list. If L2's value is smaller or equal, attach L2's node and move L2 forward. Move tail forward so it always points to the last node in the merged list. Once one list is empty, attach the remaining nodes of the other list. No need to compare anymore. The remaining list is already sorted. Return the merged list starting after the dummy node. This is the actual head of the merged list. And that's how this algorithm works. It first sets up a dummy node and tail pointer, then iteratively picks the smaller node from the two lists, and finally attaches any remaining nodes. Efficient, simple, and elegant. Time complexity is O(m) plus n, as each node is processed once. Space complexity is O(1), because no extra nodes are created, just pointers are adjusted. Using a dummy node simplifies edge cases. The iterative approach avoids the extra call stack used in recursion.
Let's test our merge two lists function. We have list 1 equals 1, 2, 4, and list 2 equals 1, 3, 4. Our goal is to merge them into one sorted list. We use a dummy node and a tail pointer, then compare nodes from both lists, attaching the smaller one each time. We continue until all nodes are merged. The result is 1, 1, 2, 3, 4, 4, confirming our function works correctly. This implementation merges two sorted lists efficiently and keeps the order intact.
This solution merges two sorted linked lists using recursion. Instead of iterating, it breaks the problem into smaller pieces. It picks the smaller head node, then recursively merges the rest. This is very elegant and clean, especially for those comfortable with thinking recursively. Time complexity is O(m) plus n, where m is the number of nodes in list L1 and n is the number of nodes in list L2. Each node is visited exactly once. Define a class solution and the function merge two lists. If L1 is empty, we simply return L2. Nothing more to merge from L1. Similarly, if L2 is empty, we return L1. These base cases stop the recursion. If L1's value is smaller, L1 will be the next node in the merged list. Then we recursively merge the rest of L1, L1.next, with L2. Finally, return L1 as the head of the merged list. If L2's value is smaller or equal, L2 becomes the next node. Recursively merge L1 with the rest of L2, L2.next. Return L2 as the head of the merged list. This recursive solution is elegant but uses stack memory, OM plus N space. Base cases handle empty lists cleanly. Each node is processed exactly once, giving OM plus N time. Recursion naturally handles the merge the rest logic automatically.
Let's test our merge2lists function. We have list1 equals 1, 2, 4, and list2 equals 1, 3, 4. Our goal is to merge them into one sorted list. We use a dummy node and a tail pointer, then compare nodes from both lists, attaching the smaller one each time. We continue until all nodes are merged. The result is 1, 1, 2, 3, 4, 4, confirming our function works correctly. This implementation merges two sorted lists efficiently and keeps the order intact.
Let's wrap up the merge two sorted lists problem. This is a classic Phong favorite because it tests both your pointer skills and your ability to merge sequences efficiently. Master this, and you can handle merging tasks in interviews like a pro. Breakdown recap. Conceptually, we're given two sorted linked lists, and our goal is to combine them into a single, sorted linked list. The key is to reuse the existing nodes rather than creating extra arrays or data structures. Assess recap. A brute force approach would be to gather all values, sort them, and build a new list, but that wastes space and time. The optimal approach uses two pointers, one for each list, and merges nodes step by step. This keeps the process in linear time with constant extra space. Structure recap. Here's the plan. Create a dummy node to act as the head of the merged list. Use a tail pointer to track the end of the merged list. While both lists have nodes, compare their values and attach the smaller node to tail. Advance the pointer in the list from which the node was chosen. Once one list is exhausted, attach the remainder of the other list. Implement recap. We implemented this with a dummy node and a tail pointer, iteratively comparing nodes and building the merged list. Running it on LeetCode, the solution executed smoothly without errors. Check recap. Edge cases, such as empty lists, also returned correct results. Time complexity is ON plus M, and space is O1. Closing insight. The main takeaway? Merging sorted lists is all about careful pointer management. By comparing nodes step by step and reusing the existing structure, you get an elegant, efficient solution every time, a must-have skill for linked list mastery.